You fall asleep. Your body goes still. Your breathing slows. The room disappears. And then you are running, or falling, or standing in a room full of people you have never met, in a place that somehow feels like home. Your alarm goes off, and the whole thing dissolves. Here is what nobody ever tells you. Your brain never stopped working. It was running one of the most complex programs in the known universe, and it had a reason. Number 1. The story begins in a darkened laboratory at the University of Chicago, 1952. Eugene Aserinsky, a young researcher, leans over a sleeping subject, tracing jagged lines on a moving strip of paper. What he sees is startling. Bursts of rapid eye movement repeat in cycles through the night. Each time he wakes his subjects during these eye bursts, they describe vivid dreams. For the first time, dreaming is anchored to a physical event in the brain: REM sleep. Aserinsky's findings, published with Nathaniel Kleitman in Science in 1953, shatter the old belief that sleep is a time of quiet brain idling. Instead, the brain is pulsing with activity, cycling through REM stages several times each night. The original lab notes and oculograph traces, now preserved in Chicago's archives, mark the birth of modern dream science, a discovery that transforms the mystery of dreams into a question of biology, not magic. In second place, REM sleep reveals its true paradox. The body lies perfectly still, paralyzed by a powerful shutdown of the motor system, which scientists call REM atonia. Glycine and GABA, released from the brainstem, silence your muscles so completely that even the wildest dream movements stay locked inside. But inside your skull, a storm is raging. The visual cortex lights up with 30% more blood flow than in waking life. The amygdala and hippocampus, your emotion and memory centers, burn with activity. Eyes dart beneath closed lids, tracking scenes only you can see. Every 90 minutes, a new REM cycle begins, but the real action comes in the final 2 hours before dawn, when REM bouts stretch to 30 minutes or more. The paradox is clear. The body is off, yet the mind is on. Vivid, emotional, and alive. This is the biological stage where dreams take shape, setting the scene for everything that follows. Number 3 on our list, the threat simulation theory, proposed by Antti Revonsuo in 2000, offers a bold answer to why our dreams so often turn dark. According to Revonsuo, dreams are not just random stories. They are mental rehearsals for danger. Your mind, in the safety of sleep, conjures up chase scenes, disasters, and predators, running you through threat after threat. In studies of children exposed to war or trauma, nightmares packed with pursuit and peril appear with striking regularity. This pattern isn't just human. REM sleep, with its vivid dream states, shows up across mammals and even in birds, hinting at an ancient, adaptive role. The theory has sparked fierce debate. Critics argue that threat-filled dreams might simply reflect the brain's way of processing strong emotions, not rehearsal. Yet the sheer frequency of high-threat imagery, chases, escapes, and confrontations remains hard to ignore. Revonsuo's theory stands as the first major evolutionary account of dream content, shifting the question from how dreams happen to why the brain keeps dreaming at all. Number 4. The spotlight turns to a laboratory breakthrough from Nature Neuroscience in 2005. In a dark maze, rats run, and their brains are wired to record every step. Later, as they slip into REM sleep, something remarkable happens. The hippocampus, the brain's memory hub, fires off rapid bursts of activity, replaying the day's journey. But this replay isn't a simple rerun. The sequences are scrambled, compressed to 20 times the speed of waking life, and often stitched together in new, unexpected orders. Using tetrode recordings and Bayesian decoding, researchers Louis and Wilson revealed that these shuffled patterns aren't random noise. Instead, they predict how well the animal will navigate the maze the next day. Here, memory isn't just stored. It's reorganized, reimagined, and prepared for future use. This is the hidden workshop of the dreaming brain, where yesterday's experiences become tomorrow's insights. Number 5. The curtain lifts on the creative power of dreaming. When you dream in REM sleep, the logical guardrails of your waking mind, the dorsolateral prefrontal cortex, quiet down. This is the secret behind Deirdre Barrett's 2010 breakthrough. In her lab, volunteers tackled the remote association task, a puzzle that asks you to link distant ideas. Those who slipped into REM during a nap solved 30% more puzzles than those who stayed in lighter sleep or stayed awake. The dreaming brain, freed from strict logic, lets memories and images collide in ways you would never allow by day. That is how Paul McCartney woke with the melody for Yesterday, and how August Kukuli glimpsed the shape of the benzene ring in a vision of a snake biting its tail. Scientists call these stories anecdotes, but the lab data is clear. REM dreaming boosts insight by letting your mind make leaps it cannot manage when awake. Here, the science moves from neural replay to real-world inspiration, hinting at how you might use your own dreams to solve stubborn problems. Number 6. The science turns practical. In 2014, a sweeping meta-analysis pulled together 35 studies and found that dreaming during REM sleep gives a measurable boost to creative problem-solving, about a 0.41 effect size. That is not just a lucky guess. It is a real statistical edge. But here is the catch. If you cut your sleep to 6 hours, you lose more than half your REM time. The final REM cycles, those last bursts before dawn, are where the brain does its most powerful work. 2 actions make that science work for you. First, keep a notebook by your bed and write down your dreams the moment you wake. Second, protect those last 2 hours of sleep. Aim for 7.5 to 8 hours, not 6. The data is clear. More REM means more creative gains. Your dreams are not noise. They are your brain's secret workshop. Subscribe for more science that changes how you sleep and how you think. Across every study, one pattern stands out. Your dreams are purposeful brain work, reshaping memory, rehearsing emotions, and sparking insight. Even asleep, your mind is never off. Subscribe for more science that unlocks you.